recording. So today's lesson is 1.5 inverse. Again, some of this is review, some of it is new. Okay, last year you looked at inverse of linear and quadratic. So one more time, the definition has not changed. Inverse is when you switch the x and the y coordinates. It's a reflection in the y equals x line. That means that if you were to look at a graph, it would be reflected in the y equals x line. So this, which is this line here. Right, so it would be reflected here. So if you folded it, if that was your fold line, then it would be like a butterfly. It would be exactly the same on both sides, right? So diagonally, that's what that means. Now, sometimes the inverse of a function is a function, and sometimes it is not, right? So if I was to take a line and then do the inverse of it and flip it along that, it would still be a line, right? So it'll still be an inverse. If I was to take a parabola, so if you say a parabola which looks kind of like this, we'll do this, whoops, so like that, and you flip it over, it becomes a positive negative square root, so it's no longer a function. It doesn't pass the vertical line test. So that's what this is saying. Sometimes the inverse of a function is a function, and sometimes when you take the inverse of it, it's no longer a function. If the original is a function, and the inverse, so if the inverse is a function, then we're going to use this little notation here with the little -1. That's only if I start you with the f of x or h of x or g of x notation. Then we do it like a matching pair. So it's like a matching pair, and I'll show you that in the first couple examples. So when we use this little notation. It's not the exponent -1. When that little -1 is used, it is a -1, so it actually physically is a -1, but when you use it on function notation, it means inverse, not to the power of -1. Okay, so it's the same symbol, but it means not to the power of -1. It means inverse of f of x, inverse of g of x, inverse of h of x. So it means inverse, not -1. Okay, here. So this first one, state the inverse of this. Okay, and I have y equals those coordinates. I want to state the inverse. Oh, I did not. Okay, so the inverse for this one is going to be, flip it, -3, 2, 6, 3, and 1, 2. Does that make sense? So flipped it, make sure I did it right, 1, 2. So state the inverse of that. Is y a function? Is this original one a function? Is y a function? This one here. It's not a function. Y is not a function. Now, how do I know it's not a function? Right here. For the original function, I have 2 y's. So it is not a function based on those two there. Does that make sense? A bit bigger. Okay, based on those two there, it is not a function because the 2 has -3 and the 2 has 1. Now, is the inverse a function? Is the inverse a function? And I'm going to have to name it something else. So I'll just name it y2. How about I just name it y2? Because I don't know if it's a function or not. I'll just name it y2. And then, is y2 a function? Yes, y2 is a function. Okay, so this is the inverse. Okay, y2 is the inverse, and y2 is a function. So that one is a function, that one is not. We're not going to match it because it doesn't have the f of x notation anyway. It's just asking a few questions. Does that make sense? All right. Now, B. If f of x equals 4x plus 1, what do we know that is? 4x plus 1 is a linear function. Determine the inverse of that original function. Okay, and I want you to graph both. So you can either graph it and then inverse it. So this is asking, this inverse part here is asking you algebraically to find the inverse, and I also want you to graph it. You can graph it and then do the algebraic, or algebraic and then graph it. It's up to you. I'm going to do the algebraic and then I'll graph it, right? But again, it's up to you which order you do it in. So my step 1, you don't have to write the steps. I'm going to put this in a bubble, is to switch f of x for y. Okay, and again, you don't have to. but you can. Okay, you can not write the steps. You don't have to write these steps at all, but for your head, in your notes, in your notes, you might want to just note this down for the first one. Okay, just for the first one, we're going to write these steps down. So equals, so all I did here was this y here. Just switch this. So 4x plus 1. Then my step 2 is switch x and y. Okay, so step 2 is switch x and y. So I'm going to do x equals 4y plus 1. So you can see, look, I only just swapped the two letters, didn't do anything else, just swapping x for y and y for x. That's like me physically taking those points and switching the x and y. So you're physically just switching the x and the y. The next step would be isolate. And so step 3 is isolate for the y. Okay, so my next step is isolate for y. So we're going to go bring the 1 over. So x minus 1 equals 4y. Divide both sides by 4. So we're going to go x minus 1 over 4 equals y. Or, don't ever give me two answers unless there actually are two answers. Here I'm just showing you there's two possible. So x over 4 minus 1 over 4 equals y. Both of those are the same. Okay, they're equivalent. It doesn't matter. Oh, I'll zoom in and then I'll just keep it on the left side of the screen. Okay, say both are the same. Now, my last step here is, okay, decide if you're going to use this notation. Okay, so you're going to decide if you're going to use this little -1 notation. Okay, so you're deciding if you're using that notation or not. Did it start with the f of x? It did. If it started with the f of x and it's still a function, then you have a matching set. It's really just a communication thing. It's just basically saying they're a matching set of functions. It doesn't change your answer. It's just the notation at the end. So this is a line. When you take the inverse of a line, it is still a line, right? We learned that last year. So it is still a line, doesn't change the fact that it's still a line, and it is still going to be a function. This one here has the y-intercept at -1/4 and the slope of 1/4, right? They're the same answer. Sometimes this one's easier to see, but it's still y equals mx plus b. So then you're going to go therefore, okay, therefore, and we're going to use this beautiful notation. Okay, so it's that notation there that we're deciding, equals, and then either version, it doesn't matter. They're both the same to me. Either that one or that one. Yep.
If you want to find out if it's an inverse function or not, can I just like plot the points first and then figure it out?
Yeah, but sometimes I don't give you the graph. Right, so you should know a line is still a line, and then you look at the exponents. The exponent of x is 1, the exponent of y is 1, it's linear. Yeah, whether or not I give you fractions. Yeah, exactly. The fractions are there on purpose. I gave you that on purpose because that throws you off. Everyone's like, is it a line? It is a line with a bunch of fractions. Yeah. Okay, so then let's graph it. So that's why I did it algebraically, because sometimes I don't give you a grid, or the line, the points are really big or something, so you can't graph it. So from the graph, we can see that x and y. Okay, I'm going to move it over so you can't see the words, but that's okay because you have the words written down already. Okay, I'm going to swoosh it over here so you can see the graph better. I zoomed in enough. Okay. All right, so then now when you graph, my suggestion to you is to start with the easier graph, if there is one. Maybe they're both easy, right? I need you to fill the grid, right? So I don't want it to be just 2 points. I need you to use a ruler, okay, where needed. Same rules as we've had since forever. And I want arrows. where needed. Okay, so wherever you need arrows, put arrows. If you don't need arrows, don't put arrows, right? So fill the grid. Now, which one is easier to graph? X minus 1 over 4, x over 4 minus 1/4, or 4x plus 1? Yeah, 4x plus 1, because right here, I know that the b is 1 and m is 4. So the original one is a lot easier to graph just because no fraction for the y-intercept. Otherwise, it's okay. The fraction for the slope is okay, but the y-intercept is a pain in the neck because you got to go by quarter points, and it's really hard. You can't be accurate with that, right? So then let's start with this one, and I'll show you for the inverse. Okay, so we got this one. So we're going to go b is 1. B is 1. So right here. Okay, m is 4, the slope is 4, so up 4 over 1. I can't do any more. I'm going to go backwards. Down 4 over 1, down 4 over 1. So fill the grid as much as you can. Ruler wherever necessary, and arrows wherever necessary, and I'll label that f of x. Okay, now that is the original function. If I want to do the inverse of that, I can start with the y-intercept of -1/4. Ugh, yuck, fractions, you can't really do it accurately. So what you could do is what I was talking about up here in the question above, switch the x and the y coordinates. I don't need you to label the coordinates, but for this one I'm just going to do it 0, 1. Again, I'm going to put it in a bubble because you don't have to. Flip the x and the y. So it's 1, 0. So 1, 0. Again, you don't have to label it. I'm just doing it for our notes. So 0, 1 becomes 1, 0. This one is 1, 5. Okay, you don't have to label that, but so you know it becomes 5, 1. Does that make sense? So you're taking all these points. This will be -1, -3, so -3, -1. This is -2, -7, so 3, 4, 5, 6, 7, -2, like that. Okay, so you don't have to label the coordinates. Remember, the stuff in the bubble is just for your notes, and then you're graphing it. And this is the inverse. There you go. So start with the easier one and then use that to help you out. Okay, you don't have to start with the inverse. You don't even have to use the quarter point. You can just use the coordinates from the original. Any questions or clarification? Yep.
Do we also have to draw the y equals of x?
No, you don't. So it's up to you. If you want to, you can. Some people do it to check their answer, but you don't have to. Okay, unless I say draw the reflection line, you do not have to. Yeah, so the question was this one here. You can if you want. Some people go, oh, you know, I like to see that it's perfectly symmetrical. So put dot, dot. If you do draw it, it's not a solid line, right? It's a dash line because it's not part of your graph, so it's just a dash. It's just a guideline, but not part of your graph. Okay, so if you want to, feel free to, but you don't have to. Any other questions? Okay, flip over when you're ready. Okay, so this next one here is the lovely parabola, right? Graph of a parabola. We're going to determine the inverse and graph both. Again, you can graph it first and do that part, or you can do it algebraically. I'm just going to do the algebra and then I'll do the graph. Okay, and again, either order is fine. It's totally up to you. So I'm going to do same thing. So step one, you don't have to label it. I switched the f of x, but I didn't have f of x or notation, so I'm going to go ahead and switch x for y. So we're going to go x equals. I know some teachers made you write subbing in or for the inverse. You can do that. I won't make you. Right, so if you just switch the x and the y, then you can go ahead and do that. And again, I know some teachers have you write that step, which is actually better than me. I'm being lazy / nice. Okay, but you can definitely write that step, right? I'm switching the x and the y for the inverse. So switch those two. You don't have to highlight, I'm just showing you what I'm doing. I just go right into the calculation. Okay, so switch those two, and now isolate. So we're going to bring the 3 over first. So this will be x minus 3 equals negative 2, y plus 4 all squared. Divide both sides by the negative 2. You can do the whole thing or each one, up to you. And you can't leave the negative on the bottom, right? And again, we've been telling you that since grade 9, bad forms. We're going to leave negative x plus 3, or it can be factored out, up to you, but you just don't leave the negative here on the bottom, right? So this negative here, just make sure you move that up, equals y plus 4 squared. Then, to get rid of the squared, use square root. On this step, I do require you to put positive negative square root. Okay, you can't add it later. Sometimes people are sloppy and they add it later. I want it on this next step. So if you're going to get rid of it here, then you can put it on that step, and if not, on this next step. As soon as you write that square root, I want the positive negative. Some people write it right on the question, that's fine, or you can write it here on this next step. Up to you. Okay, wherever you write it, though, there's a positive negative. Right, so again, I'm just going to show you what I mean. Some people do this. I'll do it in orange. Some people do this right on it. That's fine. You don't have to show me that, but if you do, can you please put plus minus. So that one here, and some people go right into the next step and write it. Either way, but you have to put the plus minus. I'm going to highlight the plus minus. Okay, so if you include that step, that's okay, but make sure the plus minus. Some people fix it the next step, but suddenly there wasn't a plus minus, but now there is, so put it as soon as you put it. Okay, so that cancels that one out. Now, anything else? The 4. So, oh, sorry, can I also point out, okay, it's not about neatness. I'm not marking neatness, I'm marking accuracy. Make sure, see how I'm square rooting the whole side? I need this to go all the way down to the bottom, to the 2. Some people kind of put it halfway in between, but then if it's not in the square root, that means it's a vertical transformation. If it's in the square root, it's horizontal. Right? So you know it means two different things. In the square root means it's with the x. Out of the square root means it's not with the x. So you do have to make sure that that goes all the way down to the bottom of the 2. Make sure it's clear. If it's halfway here on that halfway part, the dividing line, I'm not giving you the mark. Okay, because you're not being clear. So it's not about neatness. I'm not marking neatness, I'm marking accuracy, like down to the bottom of the 2. Yep. You don't need a bracket, so don't put an extra bracket. Yeah, because then you're putting extra brackets where it's not needed. No. Okay, so then the 4 comes over, so now be careful a little bit here, because if you bring the 4 over, so it's plus minus, you see how I have negative x plus 3 over 2? I'm very clear. The square root goes to the bottom of the 2. It's easy to do, just don't put